Here the statement is, find the lateral shift of light ray while it passes through a parallel glass slab of thickness 10 centimeter. Placed in air. The glass slab is being placed in air as the surrounding medium, right? The angle of incidence is given to be 60 degrees and the angle of refraction within the glass is given to be 45 degrees, correct? Let's look into the figure part of it. This is how it looks. This is how it goes, how it is formed. Please understand a few things here. See, if you start from O, that is the object. You take a ray which is emerging out from O and you take that as an incident ray, right? Let's say we take this as incident ray. So this incidents onto the glass slab, if you see, onto surface S1, if you see, at an angle of incidence given to be 60 degrees, correct? So this is 60 degrees, this is the normal, and this is 60 degrees. Now what happens when it enters into glass medium? It bends towards the normal because it is going from air to glass, from a rarer medium to a denser medium. So for the surface 1, S1, it shifts towards the, it bends towards the normal. It might have gone like this if it was air, if there was no refraction, it might have gone like this, but it bends. So it bends and it goes like this into the medium. And then the angle of refraction is given to be 45 degrees, correct? Now, this ray, this refracted ray from the first surface becomes the incident ray for the second surface, correct? Now, for the second surface S2, let's say, again the refraction takes place, but this time the refraction is from glass to air, from a denser medium to a rarer medium. So it might have gone like this, but it shifts away from the normal. This is the normal 2. It shifts away from the normal and it actually goes like this, correct? You need to understand one thing. Because the glass slab is having both the surfaces parallel to each other, first of all, and both the surrounding mediums, here and here. On both sides, the surrounding medium is air. So whenever such system is given, when a glass slab is given with the two surfaces parallel, of course, where the refraction is taking place, and the surrounding medium is same, then what you can get is this angle of incidence 60 degrees will be equal to angle of escape. E is equal to 60 degrees, right? Because you apply Snell's law on both the surfaces and you will get I is equal to E, correct? But for such systems where S1 is parallel to S2, condition number 1, check number 1, and check 2 is the surrounding medium should be same, should be common. It's not like here it's air, here it's water. Then I will not be equal to E, right? Okay. Now, if you see this and this angle, they are equal. Then if you understand this, if you see this, then this ray, what was the original ray without any refraction before the first refraction, the original ray, and the final ray, which actually comes out as a refracted ray, as a final refracted ray, they are parallelly shifted. Are they parallelly shifted? Yes, because I is equal to E. So if they are parallelly shifted, the perpendicular distance or the perpendicular shift which they have in between is called lateral shift. Lateral shift is defined for a particular incident ray. If you take different incident ray, see, there are multiple rays emerging out from the object. So you can take any other ray which makes an angle which makes an incident angle not 60 degrees, maybe 70 degrees, right? Then for that, the lateral shift will be something else, right? But for a particular ray, if we talk about for a particular ray, the incident ray, the initial incident ray and the final refracted ray, they are perpendicularly shifted. If they are perpendicularly shifted, then that perpendicular shift for that particular ray is known as lateral shift. See, it is not the shifting in between the object and the final image. It's not OI. It's this. Correct? And for the lateral shifting, so you should understand when lateral shift appears. It appears when S1 parallel to S2 and both the surrounding medium on both the sides it's same. Correct? So that's condition number 1. Those are the conditions, right? And then What is lateral shift? It is the perpendicular shift in between the parallel set of incident ray and the refracted ray. Correct? Okay. Now, if you remember the formula for lateral shifting, okay, let's use this only. The formula for lateral shifting is given by this thing. So if you remember, the lateral shift D is given by T sec R into sine of I minus R. Sir, what is T? See, D is the lateral shift and T is the thickness of the slab. So what is the thickness of the slab given here? 10 centimeter, right? So D must be equal to 10 times sec of R. What is R? R is the angle of refraction. Angle of refraction within the slab is 45 degrees. So it's sec 45. Multiplied by sine I minus R. What is I? 60. What is R? 45. Sine I minus R is correct. So D will be equal to 10 sec R is 1 by cos R, that is 1 by cos 45, that is 1 by root 2, that's root 2. You can directly actually write sec 45 is equal to root 2. No need to do it 1 by cos 45. But yeah, it's root 2, right? Multiplied by sine 50. So it actually appears to be 10 root 2 into sine 15 degrees. If I ask you a simple doubt, if I give you a simple problem, will it be same for all the incident rays? No. It depends on the angle of incidence. So say for example, you take a different ray with a different angle of incidence, the parallel shift, the lateral shift will be different. Correct? So it is the lateral shift for this particular ray, which is having an angle of incidence 60 degree and the angle of refraction as 45 degrees. Correct? So the answer to this problem will be 10 root 2 sine 15 degrees. Let's look into the answer. Where's the answer? 10 root 2 sine 15 degrees in centimeter. That's my answer. Option A will be the correct option in this case. This is a trick problem. Why? Because of the location of the observer, if you see. I'll explain this. What's the catch here? But let's first read out the problem. What will be the depth of object O for an observer just below the interface CD if the refractive index are given in the following order? mu3 greater than mu2 greater than mu1. Understand this. Please understand this. It all depends on where the observer is, because see, let's look into the diagram first. Correct? Now, there's an object O. Incident rays will be emerging from the object O, or the rays will be coming out from the object O, which finally be after refraction, which finally will reach to the observer and they will form image. Correct? So say for example, these are the rays. One incident ray I take from O directly perpendicular to the interface. So it will directly go like this. And the other incident ray, I can take this, which after refraction from the surface 1, that is AB interface, that is mu1, mu2 interface, will bend towards the normal or away from the normal. Please think of it. So if you look into it, mu2 greater than mu1. So it's going from rarer to denser. So it will shift, or it will bend away, or it will bend towards the normal. Correct? So it bends towards the normal and finally it reaches to the observer. Before the refraction from S2. S2 does not contribute refraction here. Why? Why surface CD is not responsible for the refraction? Because the observer is before CD. Observer is just before CD. So before the second refraction, it will be captured by the observer. Now this is refracted ray 1 and this is refracted ray 2. And what is the definition of image formed by the refracted rays? It's the intersection point of the refracted rays. So one refracted ray seems to be coming out from this line, along this line, and the other refracted ray seems to be coming out from this line. So they are actually, or virtually, they are intersecting each other at I. So that's why the image of O is formed at I. Now there is a shifting. There's a shifting of image as, or like with respect to object, right? Now please understand this. This shifting is due to parallel slab system. Can we take these two as a parallel slab system? For mu1 and mu2, can we take that? Yes, we can take that as a parallel slab system, right? Now, if you remember, I told you a formula for the apparent position of the image for the parallel slab system in the previous DPP 11, I guess. We used a formula. D apparent is given by mu of the medium where the final refracted rays are there. Please understand this. Mu of medium where the final refracted rays are there into summation of T by mu. If you remember that. If you remember that correctly. For multiple slab system, the apparent height was given by, or the apparent depth was given by this formula. Where mu r, here the important point is to understand what is mu r. Mu r is the refractive index of the medium where the final refracted rays are present. Here the final refracted rays are present in mu3 or mu2. Answer is mu2. Why mu2? Because the observer itself is in mu2. So before the second refraction or before the rays going into mu3, it will be captured by the observer, right? So the refracted rays for our purpose in this case are present in mu2 only, correct? So mu r will be mu2 into summation of T by mu. Now this much length, T2 length, is being traveled in mu2 medium. So T2 by mu2. Because you have to get the shift from CD, right? So from CD, if you have to get the shift, then CA, that is T2 length, is being traveled in mu2, and A to this interface, the bottom interface, A to O, that length, A to, let's say it's A, B, C, D. Okay, let's say it's X. So A to X, that is T1, is being traveled in mu1. So that much T1 will be divided by mu1. That's summation T by mu. Do you understand summation T by mu? Yes. You have to take it from the point where you want to calculate the depth from. We want to calculate in this problem the depth of the image I from CD interface. So that's why I have taken CA divided by mu2 plus AX divided by mu1. That's T2 divided by mu2 plus T1 divided by mu1. So what is the apparent depth of the image from CD? It will be mu2. Do you understand why mu2? Mu r is mu2. Mu r is the refractive index of the medium where the final refracted rays are present. For our purpose, the final refracted rays are in mu2. They are not going into mu3. Why they are not going into mu3? Because observer itself is in mu2. So it is capturing the refracted rays before the second refraction, right? Okay, so it's mu2 into T2 by mu2. Now it becomes simple, no? T1 by mu1. It becomes so simple. The apparent of the image from CD will be equal to, tell me, T2 plus T1 times mu2 by mu1. Correct? Am I absolutely clear? Okay, let's look into the answer. That's my answer. That's the correct thing we have derived, right? Let's look into the options. Option C will be the correct option in this case. This is again a very important problem based on the concept of apparent depth provided by the combination of slabs, you can say, right? So let's look into the problem first, then we'll discuss how to solve this. How to solve this using formulation, how to solve this using common sense. But the common formula we have already discussed, right? So the statement is, for the observer just above the medium one. In all these problems, the location of observer is very important, right? As you have seen in the previous problem. Mu r was taken to be mu2, not mu3, right? Just in the previous problem. In this problem also, if you see, for the observer just above the medium 1. What is medium 1? That is given to be mu1 is equal to 4 by 3. That's this, right? That's this. The shift in the position of coin which is at the bottom, right? For the arrangement shown in the figure. Now, how the arrangement is shown is this. Mu1, mu2 is given to you, and the thickness is also given to you. The thickness of the medium is also given to you, right? So you can say T for the mediums are given to you and mu for the mediums are given to you, right? The location of the observer is given to you. It is above mu1 and nothing is being said about the observer's medium, so let's say it is air. If nothing is being given about the observer, and of course it's not unknown, the medium of the observer is not one of the unknowns, then by default it is to be taken as air with mu is equal to 1. In that case, you are supposed to get how much the image of the coin is away from the coin. What is the shift in the image, right? What is the shift produced by the system? Now this system, if you see, again can be taken as two parallel slabs of different mu, of different thickness, correct? Now let's think of it. Let's think of it in this manner. We have to visualize the medium as transparent slab and apply the principle of superposition to get the net shift in the position of object. We can do that like this, or we can use something else. What something else we will discuss in the end of this problem, right? So okay, now if you take this system and you apply the formula for shifting for each of the slab. For the given data, this is the system given, T1 mu1, T2 mu2. And for each slab, the shift is provided by this formula. You might have read this formula, right? When the observer is in air, right? So this is the shifting which is provided for each slab which is having T as the thickness and mu is the refractive index. Please remember that this is the case when the observer is taken in the air, correct? The medium of the observer is to be taken as air. This formula is valid only when. Okay, so basically the shift provided by this medium and this medium as total will be equal to S1 plus S2. So that's equal to T1 times 1 minus 1 by mu1 plus S2 is what? T2 times 1 minus 1 by mu2. Some of you might find it very easy to apply the formula and get the answer. Actually, it is easy. What is T1? T1 is 16. Into 1 minus 1 by mu1, 1 by 4 by 3. That's 3 by 4. I'll write it 3 by 4, correct? So it's 1 minus 3 by 4. Plus T2. What's T2? 9. Not bad. 1 minus 1 by mu2. 1 by 1 by... So it's like 1 minus 1 by 3 by 2. That's 2 by 3, right? What is that? That comes out to be, comes out to be 4 plus this comes out to be 3, which comes out to be 7 centimeter. So you should understand that the total shift provided is 7 centimeter. That's absolutely correct using this formula. I have no issues with that. That's a very good thing. You should remember this formula when the observer, but this formula is valid when the observer is in air, right? Mu is equal to 1. Can we do it using something we have already studied? Yes. What to do? See, the given data is again this. This is the given data. I am going to use this to derive the result by certain different logic, right? Okay. I will not use the formula for shifting of a slab or via slab. I will use the general formula for getting D apparent, and then I will subtract D real and D apparent to get my answer. Do you understand my point? See, okay, from here, if you see, the observer is in air. So what is the apparent depth of coin? That is the location of image from the first surface S1. Let's say this is the surface S2. What is the apparent depth of coin? D apparent. What is the apparent depth of coin? The apparent depth of coin is given by the formula you have already studied for multiple parallel slabs. What is the formula? Mu, where the refracted rays are present, into summation of T by mu. Do you remember that? Yes. Mu, where the refracted rays, final refracted rays are present. Where the final refracted rays are present? The final refracted rays are to be captured by the observer. So where are the final refracted rays? In air, right? So that's 1. Into summation of T by mu for every medium from where we have to locate the image. We have to locate the distance of the image from S1. So I will start from S1. So I will go down. What is this distance? That's 16, right? So it's, okay, it's 16 divided by mu. Mu is 4 by 3 for that, correct? plus I have to travel more to reach the coin. How much? 9 centimeter divided by 3 by 2. If you look into that, that becomes 12 plus 6, which is equal to 18 centimeter. Now the formula says the image is at 18 centimeter from there. That's what D apparent means, right? So the distance, the perpendicular distance of the image from the first interface is 18 centimeter. That is what your formula is telling you, right? And where is the coin actually? The coin is actually at a distance 16 plus 9. Correct? So the coin is at 25 centimeter. Coin is actually at 25 centimeter, but it is appearing to be at 18 centimeter because the image is appearing at 18 centimeter. So what is the shifting? Shifting is not D apparent. Shifting is delta D, right? That's D real difference D image or D apparent, I can say. Correct? So with the help of this formula also you can get the result. If you want to remember the previous formula, shifting of a slab, that's good for you. Good for the examination purpose. But this also is fine because that formula is derived from this basic format only, right? S is equal to shift is equal to T times 1 minus 1 by mu for a slab. That is derived from this only. You can do that by doing some common sense, right? Okay, so D real is what? 25 centimeter. Take the difference from 18 centimeter. 25 centimeter and 18 centimeter. They have a difference of 7 centimeter, right? Correct. So the answer again comes out to be 7 centimeter. Whatever method you like, you can use, or you can actually understand both of the methods, right? Okay. Now let's look into the answer. Option C will be the correct option, and a takeaway message. You should remember this formula. Formula for shifting via a parallel slab. This will be helpful in the examination to save some time, right? Okay, so option C will be my correct option in this case. Here the statement is, a ray of light is incident on a glass plate. The light ray travels a distance of 5 centimeter inside the glass plate before emerging out of the glass plate. If the incident ray suffers a deviation of 30 degrees, the perpendicular distance between the incident and the emergent ray is, right? This is the situation given to you. This is the situation given to you, right? The incident ray is suffering a deviation of 30 degrees. It undergoes a deviation of 30 degrees, right? That means it deviates from its original path by 30 degrees at the point of refraction. See, this is how it is, right? It might have gone straight without refraction, but due to refraction on surface 1, it deviates by 30 degrees. Deviation is given to be 30 degrees, correct? Okay. And then what are you supposed to get? You're supposed to get the perpendicular distance between the initial incident ray and the direction of final emergent ray. That means you're supposed to get Mn. That is the lateral shift, right? We just have discussed. This is the lateral shift, the perpendicular distance between the initial incident ray and the final emergent ray. That we know as lateral shifting, correct? Okay. Sir, lateral shifting, okay. I have been given that the light ray travels a distance of 5 centimeter inside the glass plate. Does that mean the thickness is 5 centimeter? No, the thickness is not 5 centimeter. T is not equal to 5 centimeter. It travels by a distance inside the glass plate by 5 centimeter. That means T is not equal to 5 centimeter. PM is given to be equal to 5 centimeter in the figure. It travels a distance of 5 centimeter inside the glass plate. So P to M is 5 centimeter. T is not 5 centimeter, right? Okay, sir. So we have to get lateral shift, so we can use the formula. I have just told you, right? What was the formula? For the lateral shifting, D is equal to T sec R or 1 by cos R into sine of I minus R. What do we know in that? You might be thinking, right? What is I minus R? I minus R, okay, sir. Sir, this is complete I because opposite angle, right? I. So I is equal to R plus 30. From geometry, I can say that. Correct? So I minus R is equal to 30 degrees. You might be happy, sir. We got I minus R as 30 degrees. Our problem is solved. No, it's not. Why it's not? Because the value of R is not given to you. The value of I is not given to you. The value of mu in the glass is not given to you. So you cannot apply even Snell's law and get the value of I, R or something, right? You cannot relate I and R. What to do next? T is also unknown, right? So there seems a lot of confusion. How to solve this? Okay, please understand this. Please understand one more thing. Before applying the formula directly for something, first you apply your common sense, right? Then formula, if required. Formula is not required in this case. So what are you saying? Lateral shift without formula? Yes. How? See, I'll use geometry and a little bit of common sense, of course. So PM is 5 centimeter. This is 5 centimeter, right? And you are supposed to get MN. And you have been given this angle 30 degrees. Done. It's done. Without formula, it's done. How? See this. P, M, N. And this. Sorry. This. And this is perpendicular, right? This is perpendicular. This is the perpendicular you draw from there, right? So if this is 90 and this is 30 degrees and this is 5 centimeter. In the triangle PMN, please look into it. PMN, what is the value of sine 30? Sine 30 is perpendicular 30, the front side, that's MN. So perpendicular is MN upon hypotenuse. What is hypotenuse? 5 centimeter, correct? So MN, which we have to get, is 5 sine 30. That's 5 by 2. That's 2.5 centimeter. Isn't it simple? So yes, formula is important, but common sense is more important. Here we do not at all need the formula. We just need to apply some logic, some geometry, and we are done with the problem. So the answer to this problem is given to be MN is equal to 2.5 centimeter. Let's look into the options. Option B will be the correct option in this case. This again is a problem based on the formulation of lateral shifting in between an incident ray and the final emergent ray, right? Via glass slab. Not a tricky one, just the formulation part, but what you need to be clear about is that you do the proper calculations, because this is more related to data given and calculating it in a right way, right? So the statement is a ray of light falls at an angle of 30 degrees onto a plain parallel glass plate. That's this 30 degrees. And it leaves parallel to initial ray. Leaves parallel. So there will be a shifting, a lateral shifting. What is the thickness of the plate? That's T. If the distance between the direction of incident ray and the emergent ray is 3.82 centimeter. That means it is saying to you that the lateral shift is 3.82 centimeter. The distance, the perpendicular distance between the incident ray and the emergent ray is 3.82 centimeter. What does that mean? That means they are perpendicularly shifted by 3.82 centimeter. That means the lateral shifting is 3.82 centimeter, correct? You have been given so many values: mu g, sine inverse 1 by 3, cos of 19.5 degrees, sine of 10.5 degrees. All these data in this case will be important because you need to calculate a lot of things in order to calculate T, right? So this is the system given. You know the formula B, that is the lateral shifting, is equal to T sine I minus R divided by cos R. You are absolutely clear with that. You have used it for 3 times, at least in this DPP only, right? 3 or 4 times. From this formula, you need to calculate T. But for that, you need to know the rest of the things, right? The rest of the things like I, which you already know. What is I? I is 30 degrees. That's correct. D, you already know, is 3.82 centimeter. What you don't know is R. So first and foremost thing is to calculate the value of R, right? Then we'll use this formula to get the value of T, and that is it. How to get R? On the surface 1, apply the Snell's law. 1 sine incident, that is 30, is equal to mu glass 1.5 into sine of R. Absolutely clear? No problem with that. So sine R comes out to be, okay, sine R comes out to be 1 by 2 into 1.5. That is 1 by 3. Sine R as 1 by 3, R will be sine inverse 1 by 3. Am I correct? Sine inverse 1 by 3. R will be equal to 19.5 degrees. You don't need to learn the value of sine 19.5 degrees as 1 by 3. You don't need to mug it up. Just use it because this is given to you. If such random values of angle are to be used, then they will be given in the or there will be a way to calculate in the problem itself. You don't need to remember that sine 19.5 degrees is equal to 1 by 3. These are not the common values you should remember. But it's okay. This is given to you in the problem statement only. Correct? Okay. So R is known. Now, what is I minus R? Because I need sine I minus R in this formula. What is I minus R? I minus R is 30 degrees minus 19.5 degrees. What is that? That is 10.5 degrees. Correct. Now you apply this formula. D is equal to T sine I minus R is 10.5 degrees divided by cos R. What is R? R is 19.5 degrees. Okay, now it's done. It's done. T is equal to D times cos 19.5 degrees. D times cos 19.5 degrees. D is 3.82 into cos 19.5, 0.94 divided by, sorry, sine 10.5. D, okay. Let me do this. T is equal to, correct, I was correct. D into cos 19.5. D comes out to be 3.82 into cos 19.5, that's 0.94 divided by sine 10.5. Sine 10.5 is 0.18. Correct? So, okay, let's just calculate this again in this page. Okay, what was T? T is D, that is 3.82 into 0.94 divided by 0.18. This was in centimeter and all these were angles. So the value of T as calculated by this formula will be in centimeter. So this, if you calculate, comes out to be 19.9 centimeter. 19.9, you can go up to more places or after decimals, after like one place, but it approximately equal to 19.9 centimeter. Correct? Now if you convert that into meter, that's 0.199 meter. That's almost 0.2 meter. Almost 0.2 meters. So the answer to this problem will be the thickness of the slab must be around 0.2 meters. Correct? The answer to this problem will be T is equal to 0.2 meters. Let's look into the options. Option C in this case will be the correct option.